Behind every efficient HVAC system is a hidden lifeline, the refrigerant lines. These lines don't just carry refrigerant, they determine how well your system cools, heats, and performs overall. The truth is, choosing the right size refrigerant line can be the difference between a system that runs smoothly and one that struggles to keep up. In today's training, we're breaking down why line sizing matters and how it impacts efficiency, reliability, and your bottom line. Selecting the correct refrigerant line size for each BTU rating is critical to system performance. Oversizing or undersizing these lines can lead to major problems: reduced cooling capacity, higher energy consumption, oil return issues, and even premature compressor failure. By matching the line size to the system's BTU rating, you ensure proper refrigerant flow, efficient heat transfer, and long-term reliability. Think of it as setting the foundation. Get the line sizing right and the entire system runs smoother, quieter, and more efficiently. Here's a quick guide to common system sizes and their matching refrigerant line requirements. A 12,000 BTU system, or 1 ton, typically uses a 1/4-inch liquid line and a 3/8 suction line. A 1.5 ton system, or 18,000 BTUs, still uses a 1/4-inch liquid line, but steps up to a 1/2-inch suction line. A 2 ton system, 24,000 BTUs, usually requires a 3/8 liquid line and a 5/8 suction line. Moving up to a 2.5 ton system, or 30,000 BTUs, that's a 3/8 liquid line and a 3/4 suction line. For a 3 ton system, 36,000 BTUs, the size remains 3/8 liquid with a 3/4 suction line. A 3.5 ton system, or 42,000 BTUs, keeps the 3/8 liquid line, but the suction line increases to 7/8. A 4 ton system, 48,000 BTUs, also uses a 3/8 liquid line and a 7/8 suction line. And finally, a 5 ton system, 60,000 BTUs, requires a 3/8 liquid line paired with a 1 1/8 inch suction line. Remember, these are standard guidelines, but always check the manufacturer's specifications and adjust for line length when necessary. Proper torque settings and flares are essential to prevent leaks. A slight miscalculation can lead to costly repairs. Let's ensure your system remains leak-free and efficient. Before pulling a vacuum, a nitrogen pressure test is your first line of defense. It helps identify leaks early, saving time and resources. Let's explore how this simple step can safeguard your system. Always check thoroughly for leaks before pulling a vacuum. This step ensures the system is completely sealed and ready for operation. Skipping a leak test can lead to refrigerant loss, poor system performance, and costly callbacks. A leak-free system is the foundation for optimal efficiency, reliable cooling, and long equipment life, so never skip it. Once leak testing is complete, the next step is connecting and running the vacuum pump. Pulling the system down to below 500 microns is essential. This deep vacuum removes moisture and non-condensables, ensuring the line set is clean, dry, and fully prepared to accept refrigerant without any issues. Pulling a proper vacuum does more than just prep the system. It removes moisture, air, and other contaminants that can cause long-term damage. It also confirms that your line set is leak-free and fully sealed. This step is non-negotiable if you want to prevent future refrigerant leaks, maintain peak efficiency, and extend the life of the entire system. Skipping or rushing a vacuum is one of the fastest ways to ruin performance and shorten equipment lifespan. Condensation occurs when warm air meets a cold surface, like a soda can on a hot day. Proper drainage prevents water damage and ensures your system runs smoothly. Whenever possible, gravity-fed systems are the first choice for condensate drainage because they are simple, reliable, and require minimal maintenance. But in situations where proper slope or elevation can't be achieved, pump systems are used instead. While pumps allow for more flexible installation, they also introduce added maintenance requirements and a higher risk of failure. Both methods have their place. Understanding when and how to use each one is key to preventing water damage and keeping the system running smoothly. Understanding why leaks happen is essential. Clogged drain lines can result from dirt or algae, blocking water flow. Improper slopes can cause water to pool instead of draining. Damaged pans with rust or cracks let water escape. Safety switches are crucial, shutting off the system if water backs up, preventing damage to your home. To prevent AC leaks, install a float switch, use a secondary drain pan, clear the drain line with vinegar, and inspect the pan regularly. Schedule yearly professional maintenance. Tip: if your AC suddenly shuts off, check the drain line for clogs first. Always confirm successful water discharge post-installation. This simple test can prevent future service calls and ensure system reliability. By understanding and applying these techniques, you'll ensure a reliable HVAC system. Remember, proper installation and testing are your best defenses against common issues. Thanks for watching. If you found this helpful, don't forget to hit that like button, share this video with others, and subscribe to the channel for more HVACR tips and tutorials. Turn on the notification bell so you never miss an update.